Hello students and friends, welcome to the thrust of curiosity. In today's video, we are going to solve determinant of this matrix. But I want to convince you that I can expand from any row or from any column and I will still get the same answer. So let's start. So first of all, I will start with the first column or start with first row. So here I will expand with this 2, then I will leave this row and column, so I will get 1 into minus 4, that is minus 4, minus 3 into 2 is 6, minus this will become plus 3. I will leave this row and column, I will get 3 into minus 4, that is minus 12, minus 5 into 3, that is minus plus 15, plus 1 into 3 into 2 is 6, minus 5. So minus will become plus. This is my determinant of this matrix using first row, expanding to first row. So I will get here minus 10 plus 3 into minus 12 plus 15 is plus 3 plus 11. So this is minus 20 plus 9 plus 11. So this is equal to 0. So the determinant of this matrix is equal to 0. Now let's solve with the second row. Okay. Now I also told you in one of the video that how we determine whether the covariance is positive or negative is by adding the indices of that. So suppose A11, A12, A13, A21, A22, A23, A31, A32, A33. So this is my matrix, and when I have to find the cofactor to find the determinant, I should add 1 plus 1, that is 2. So it is positive, it is even number, so this must be positive. 1 plus 2, 3 is odd, therefore we take negative. Here we take negative because of that. Again here 1 plus 3 is positive, so this is positive. Now because I am now expanding with the second row, I should remember that 2 plus 1 is 3, negative because it is odd number. Here plus because 4 is even, and again minus. So when I am expanding, so this is expanding first row. Now I will expand using second row. Okay. Using second row, the determinant of A. I am taking determinant of the same matrix. Okay, let's see. So I will write minus 3 here because this minus and this 3 as it is. So I will leave this column and row, and I will get this cofactor matrix. So minus 3 into minus 4, that is plus 12, minus 2. Here the middle sign will be plus. Now 1 into, I will leave this column and row, I will get 2 into minus 4, that is minus 8, minus 5 into 1, that is minus 5. So minus here will become plus 5. Again here is minus, so I will write minus 3. Now I will leave this column and row, I will get 2 into 2 is 4, minus 5 into minus 3, that is plus 15. Okay. Now I will add this minus 3 into 10 plus 1 into minus 3 minus 3 into minus 11. You can see here minus 30 plus minus 3 minus plus 33. So this will give you the answer 0. So you can expand this with any number of row or columns. I have also shown with the first row, I also shown with the second row. I can also show with one of the column. So let's start with the third column. Okay, I'm just showing you the answer will be the same. You can expand with any row or any column. Okay, so I'm going to expand with third row. So plus minus plus, right? So here is plus, here is minus. Okay. determinant of A is equal to first element is 1, that is positive, into. Now I should leave this column and that row. So 3 into 2, that is 6, minus 5 into 1, that is minus 5, minus plus. Again here will be minus 3 into. Now I will leave this column and row. Then I will get 2 into 2 minus 15, right? 2 into 2 is 4, minus 5 into minus 3 is plus 15. So here as it is. Now third element will be plus. Now there is minus 4 into. So I will leave this column and this row. So 2 into 1 minus 2 into 1 is 2 minus 3 into 3, that is minus 9. So that minus and minus will become plus. So 2 plus 9. Okay, now I will try to expand. So this is 6 plus 5 is 11 minus 3 into minus 11. So that will become plus 33 minus 4 into 11. So again here you will get 11 plus 33 minus 4 to 4. Again this will give you the answer equal to 0. So now we are clear that you can expand with any row or any column. So where does this help us? Suppose in some matrix we have more number of zeros in some particular row or particular column, then we can expand through this row or this column. Okay, so here this row or this column contains more number of zeros, so there will be only one calculation because of this. Otherwise 0 into something will be 0, 0 into something will be 0, and if you add zeros there will be no change in answer. So you can just go through this expansion through first column. So there we will get some easiness, and then we can solve very easily in quick time. So that will help you in your net set examinations. Determinant of this matrix is equal to 0. That just we have found. Trace of the matrix is equal to. Now you have to just add the elements on the diagonal. So 2, 1 and minus 4. So 2 plus 1 is 3, minus 4 means minus 1. So the matrix has 0 determinant and trace is equal to minus 1. So what we have to find out? We have to find out 3 eigenvalues such that their product is equal to 0 and their addition is equal to minus 1. So what we can do, we have, because 3 eigenvalues and product is 0, so at least one of the eigenvalue must be equal to 0. So let's try with lambda is equal to 0. So 0 is one of the eigenvalue. Now remaining 2 must have the addition is equal to minus 1. Right? Now here we cannot surely tell how can we do that, because if we have 1 and minus 2, still I will get the addition equal to minus 1. Suppose I have 0 and minus 1, then also I will get the addition minus 1. Or we can have many number of possibilities. So here we cannot directly solve with the trick. But if you have in your options, if you have such values where the product is equal to 0 and trace is equal to, that is addition of them is equal to minus 1, then you can choose that particular option. Okay, so here what we have to do, we have to go through the process and then we can find out the eigenvalue of this matrix. So the process is A minus lambda I. We have to equate this determinant equal to 0. Now if we equate this to 0, what we will get? We have to subtract this lambda from all the diagonal elements and the determinant should be equal to 0. So 2 minus lambda minus 3, 1, 3, 1 minus lambda, 3, minus 5, 2 and minus 4 minus lambda. Okay. Now this is equal to 0. Now we have to solve this determinant. Again, just we have solved determinant earlier. Same, we can find out the value expanding any row or any column. Okay. So we will go with the first row. That is just conventional thing. So here 2 minus lambda in bracket 1 minus lambda into minus 4 minus lambda minus 2 into 3 is 6. Here minus and this minus will become plus 3. So I will leave this row and column. I will get 3 into minus 4 minus lambda minus 5 into 3, that is plus 15, because minus minus will become plus. And third we have plus 1 into, I will leave this row and column. I will get 3 into 2 is 6 minus plus 5 into 1 minus lambda. So this must be equal to 0. Let me check again. So 2 minus lambda, I will leave this row and column. I will get 1 minus lambda into minus 4 minus lambda minus 2 into 3 is 6. Now here this is minus and this minus 3 will become plus 3. So I will leave this column and this row. So 3 into minus 4 minus lambda minus 5 into 3, that is minus plus 15. Then plus 1, because here is plus. Now I will leave this column and row. 3 into 2 is 6 minus, and here is minus, so plus 5 into 1 minus lambda, that is equal to 0. So we have to expand this, and after expansion we will get the equation in cubic form, or because here I have one answer equal to 0, I can get quadratic equation. Let's see how we can solve this. Okay, so expanding this, I can take this minus out from this bracket and I can change this sign. So here I will get lambda minus 2, and in the bracket I will write 1 minus lambda 4 plus lambda, because this is the product, only one of the minus sign I have taken out, and here this will become plus 6. Okay, we will solve this. Plus 3 into, okay, let's expand it. Minus 12 minus 3 into lambda. Okay, minus 3 into 4 is 12, 3 into lambda is 3 lambda, and this plus 15. Okay, now last, plus 6 plus 5 minus 5 lambda is 5 into lambda. Okay, so this total is equal to 0. Now we have to expand this and we have to add these things. Okay, therefore I will keep this as it is, lambda minus 2 inside the bracket. Now if we expand this, 4, 1 into 4 is 4, 1 into lambda is plus lambda, minus lambda into 4 is 4 lambda, minus lambda square, and this plus 6, plus 3 into minus 3 lambda, 15 minus 12 is plus 3, and here 11 minus 5 lambda, that is equal to 0. Okay, again I will expand this. 4 plus 6 is 10. Okay, so we can expand this here with the help of 1 by 1 we can multiply the number. So lambda minus 2 into, let's take 4 minus lambda square initially, then minus 4 plus 1, that is minus 3 lambda, and this plus 10, minus 9 lambda plus 9 plus 11 minus 5 lambda equal to 0. Now again I will multiply this lambda to all elements and minus 2 to all elements in this bracket. So I will get minus lambda cube minus 3 lambda square plus n lambda minus plus 2 lambda square plus 6 lambda minus 20. Now you can see here 9 plus 11 is 20. This minus 9 lambda and minus 5 lambda is equal to 0. So this plus 20 minus 20 will cancel. So there is no constant in this. So we can take lambda constant outside. Okay, we will see that shortly. Let's first add common things. So there is only one term for minus lambda cube. Then try for lambda square. There are two terms, minus 3 and plus 2. So this will be minus lambda square. Now find for lambda plus 10 plus 6 16, and 9 minus 9 minus 5 is minus 14. So 16 minus 14 is plus 2 lambda, and constant terms are gone. So this is equal to 0. Now from this we can take lambda or minus lambda constant outside. So lambda square plus lambda minus 2 is equal to 0. So this is one of the solution. Lambda is equal to 0. We have already told, because the determinant is equal to 0, there must be at least one answer that is equal to 0. Now here we can use the equation for quadratic equation. We can use if ax square plus bx plus c is equal to 0, then we have x equal to minus b plus or minus square root of b square minus 4ac divided by twice a. So we will use the same formula here and we will find out. Here you can see, okay, lambda equal to 1, this is 1 eigenvalue, because this is the product. Either this has to be 0 or this has to be 0. So minus lambda is equal to 0 means lambda equal to 0. Now we will solve for this using that formula. Minus b. B is here plus 1. Okay, a equal to 1, b equal to minus 1, and c equal to minus 2. So if I put here minus b, minus b is minus 1 plus or minus square root of b square is 1 minus 4 into a is equal to 1 and c is equal to minus 2 divided by 2 into a is 1. Now this will become 1 minus plus 2 and 4 into 8, 4 into 2 is 8. So 8 plus 1 is 3. So I will get this is equal to minus 1 plus or minus 3 upon 2. So we will get two answers, minus 1 plus 3 upon 2, that is 2 upon 2 is equal to 1, and another answer is minus 1 minus 3 upon 2, that is minus 4 upon 2, that is equal to minus 2. So my eigenvalues are 0, plus 1 and minus 2. So if you check, if we add this, we will get minus 1. And if we multiply, we will get answer equal to 0. So there are also tricks we also discussed in the last lecture, that if we have diagonal matrix or triangular matrix, then the elements on the diagonal itself are the eigenvalues. So for example, let me take one matrix and then we will stop. Suppose this is a matrix, this is a triangular matrix, so their eigenvalues must be 1 and 2. You can check. Also we will see the determinant, and determinant is equal to 2 because 2 into 1 minus 0, 2 minus 0 is equal to 2. This is my determinant, and trace is equal to 3. So if you check, 1 plus 2 is 3 and 1 into 2 is 2. So this is true for all diagonal values or triangular matrices. Okay, suppose I have n dimensional matrix, then also this will work, but the matrix has to be diagonal or triangular. Suppose 1 2 4 9 0 0 0 0 0 0, and here whatever values I have, the eigenvalues of these matrices are 1 2 4 and 9, because this is a triangular matrix. Triangular matrix means all the diagonal elements on the lower side of the diagonal are 0. This can be also on the other side also, then also we will call it as a triangular matrix. And for a diagonal matrix, only diagonal elements are non-zero, all other elements are off diagonal elements are 0. Okay, so in the next lecture we will find how to find out the eigenvector of such a matrix. Thank you for watching. Like, share and subscribe.